All right, so here we are. We finished the definite integral. And that was really important because the test 2 is going to be based on how we found the definite integral from A to B. So we found the definite integral. We got a number for our answer, but we never talked about what that number might represent. So that's what we're going to talk about in 6.4 and in 6.5. So let me just show you here. I have a definition. Oops. And let's look at this. Okay. So the integration as area. Okay. So for y is equal to f of x, a continuous function on the interval a, b, I'll tell you what that means. The integral from a to b, so we're setting up the definite integral. So here is the integral from a to b, and let me show you what that means to me. Okay, I'll just keep reading. And we set up the definite integral, and the integral from a to b represents the total area bounded by the curve f of x and the x-axis from x is equal to a to x is equal to b if your function is non-negative for all x in a, b. So what that means for us is this. If we have a function y is equal to f of x, this is our function. And this is your a, and this is your b, okay? So if we find the integral from a to b of our function, what it's going to give us is the area between the curve and the x-axis from x is equal to a to x is equal to b. So whenever you're given this interval, the a is always on the left, the b is always on the right. It represents the portion of the x-axis from x is equal to a to x is equal to b. And so when we integrate that, we get the total area bounded by the curve y is equal to f of x and the x-axis, so between the curve and the x-axis, from x is equal to a to x is equal to b. And it says f of x is non-negative for all x in AB. That means my curve doesn't dip down below the x-axis, and it doesn't for us in this particular scenario in our 6.4. So let's go see how to do that. Okay, so if in our homework, it would say find the total area bounded by the curve. No, let's say find the total area bounded by the x-axis in the curve y is equal to f of x on the interval AB. Okay, so the first three problems in your homework, this is what it's going to be. Find the area bounded by the x-axis in the curve. They're going to give us a function, like problem number 1. They give us a function, f of x is 5 plus 4x, and they give us an interval from 3 to 6. Okay, and so they want to find the area bounded by the x-axis in the curve from x is equal to a to x is equal to b. So remember from this definition that we just put up there, so if we have a continuous function on the interval, which we do, then if we set up the definite integral from a to b, a is the smaller number, it's always on the bottom, then we get the area bounded by the curve and the x-axis from x is equal to a to x is equal to b. So we're finding this area right here. So we don't have to graph the function, but to find the area, it's going to be the integral, and it's always the smaller is on the bottom of 5 plus 4x dx. So we set up the definite integral. And for all of these, our rules are going to be 6.1 rules. I've taken the substitution problems out because our time is so limited. All right, so my antiderivative is going to be rule 1, 5x plus 4x squared over 2 from 3 to 6. So we top minus bottom, f of 6 minus f of 3. Okay, now we did talk about this morning, if you don't have a calculator, you can just put the 5 times 6 plus 4 times 6 squared over 2 minus, you can do it that way. Okay, but I'm gonna use the calculator, and I'm gonna do, I'm gonna plug 6 in. So I'm gonna do my 6, store for x and enter. I'm typing my antiderivative, 5x plus 2x squared, and get 102. And then I'm gonna plug 3 in. So I'll do 3, store for x and enter, and I'll go highlight my antiderivative again and push enter twice and get 33. And remember, especially when we have decimals and stuff, but I always just go highlight the top number, 102, enter, and then I say minus, because it's always minus the bottom number, which is 33, and that gives me 69. And that number represents the area between, bounded by the curve and the x-axis from x is equal to 3 to x is equal to 6. Okay? All right. So there's another. So remember, the directions are the same for 1 through 3. We're going to find the area. They're going to give us a function. We're going to find the total area bounded by the x-axis and the curve on the given interval. So in number 2, they give us f of x is equal to 7x squared plus 4x plus 2, and the interval is from 5 to 6. Okay, so that is the question. And remember, they're asking us for the area bounded by the x-axis and the curve. Sorry, if we had graphing calculators, we'd graph it and look at it, but we don't, so we're not going to. Okay, all right, so I'm going to find the antiderivative. And remember, for us, this is all 6.1, okay? So my antiderivative is 7x cubed over 3 plus 4x squared over 2 plus 2x, and we're going to evaluate it from 5 to 6. So I'm going to plug in my top number minus my bottom number. Okay, I make my parentheses. Okay, all right. So I'm going to do 6, top minus bottom, 6, store for x and enter. Type in my antiderivative. I say 7 divided by 3, x to the third. You could say 7x to the third divided by 3. 7 divided by 3, x to the third. And when I'm up there, I have to come down from that exponent. And then plus 2x squared, plus 2x squared, plus 2x. Push enter, and I get 588. And 5, store for x and enter. And then I go up and I highlight my antiderivative. And I get 351.6667. I'm going to push the double arrow button right above the enter, and that's going to give me a fraction. And that way you never make a rounding error. 1055 divided by 3. I mean, and you could stop there. You know, I just go up and say, okay, 588, I highlighted it, I push enter, minus 1055 divided by 3, and I push enter again, and it subtracts them. 709 divided by 3. You just have to be careful because it says round to 4 decimals. Some say round to 3 decimals. If it says thousandths, it's 3. But if you leave it as a fraction, you never have to worry. So that is 709 divided by 3. Put that in. 709 divided by 3. I put the answers in, Hawk. So if I make a mistake, I'll know it immediately. Okay, so last area problem. And remember, these instructions are the same. So for these three, they're going to ask us to find the area bounded by the x-axis in the curve. So they're going to give us a curve and an interval, and we're going to go set up the definite interval. So question number 3 is f of x is 6 plus 8e to the 0.4x. And my interval is from -2 to -1. And this is along the x-axis. This is always your A, and this is always the B. This is the smaller one on the left, your x-axis from left to right. So when you set up your definite integral, this first number always goes on the bottom. 6 plus 8e to the 0.4x dx. Okay, so my antiderivative with my 6.1 rules is 6x plus, that's rule 1, 8e to the 0.4x divided by 0.4. Okay, and you can totally leave it like that. What I like to do to make it easier to put in my calculator, say 8 divided by 0.4, and I see if that makes a nice number. It does. And so I'm just going to say my antiderivative is 6x plus 20e to the 0.4x, only because it makes it easier for me to type in than instead of saying 8 divided by 0.4, but clearly it's the same thing. Okay, so we're going to evaluate it. -2 to -1, it's always the top minus the bottom. Okay. All right, so when you deal with e's, definitely you won't be able to make a fraction because it's be an irrational number. So let's do my -1, store for x and enter, always do my top. Okay, I'm going to type in my antiderivative, 6x plus 20, second function ln, and it gives you e to the blinking, 0.4x. Enter, and I write in 7.40640. It says round to the nearest thousandth, and thousandth is third. So TH and TH helps me remember. But I leave them long each time, and I don't only round it at the end. Okay, so -2, store for x and enter, and I go up and I highlight my antiderivative, and I get -3.0134. So be careful. I don't ever type those back in. I go back up and I highlight my my 7.40 number and push enter, minus my -3 number and push enter, enter, and I get 10.4198. And if I round that to 3 decimal places, I have to write it as 10.420 or 10.42, either way. Okay, all right, so that's the end of the areas in this section, and the next thing is marginal analysis, okay? All right, so in marginal analysis, we're gonna just set up the problems as well and set up the definite integrals, okay? All right, and so you'll see the problems, I have them worked out. I'm all worked out on Blackboard. So you can, and you can go open the homework and see the full question. I'm gonna write, not word for word. It says the marginal profit for a certain style of sunglasses is given by, so they give me P prime of X, which is 60 minus 0.37X. They give me the marginal profit, okay? That's dollars per pair, where X is the number of sunglasses produced and sold weekly. And it asked me to find the profit for the first 37 pair of sunglasses. For the first 37 items, we'll just say. Okay, so when they want the profit for the first 37 items, so 37 being the maximum number they want, what's the minimum number of sunglasses you could sell? I mean, what if it's, you know, rains and rains and rains? You wouldn't sell any. So when they want the profit for the first so many items, you're always just going to integrate from 0 to that number, 0 to 37. So 60 minus 0.37x dx. Okay, so, and always, these are 6.1 rules. We're not using substitution any in 6.4 or 6.5, just in 6.3b. So my antiderivative, my profit function, is 60x minus 0.37x squared over 2. Okay, so remember last time I had something like this. And what is 0.37 divided by 2? It's 0.185. All right, so I'll probably use that instead of a fraction. It's just easier for me, but you don't have to. You can leave it as 0.37 divided by 2. Okay, now I wouldn't want to round that. Like I wouldn't want to round my antiderivative. If it was never ending, you would just make a fraction out of it. You can make a fraction out of it here, 37 over 200. 0.37 over 2 or 0.185. They're all the same. That's what I'm going to use. It's just easier for me. From 0 to 37, so I have P of 37 minus P of 0. So let's go use my calculator. Okay, so let's put in 37, store for X and enter. I'll turn off my phone. And I'll type in my antiderivative, which is 60x minus 0.185x squared. Enter 1966.735 and 0, store for X and enter. And when I type that in, you get 0. And a lot of times when you plug 0 in, you get 0 to a polynomial. Just know that sometimes we plug 0 into exponential functions and it doesn't zero out. So it never hurts just to put it in the calculator. And they want all these profit, find the profit or the revenue or whatever. They want it in dollars and cents. So this is going to be 1966.74. So $1,966. And 74 cents. Okay. All right. So, and the next one, it does have an E in it. So I want to make sure I work that one for you. Okay. So again, they give you the marginal profit. It's 11 minus 0.067 e to the 0.2x. There's my marginal profit, dollars per item, where X is the number of items produced and sold. Find the profit for the first 25 items. Okay, so when we want the profit for the first 25 items, we have to set up our definite integral from 0 to 25. Okay, and then 11 minus 0.067 e to the 0.2x dx. Okay, and then again, this antiderivative will be using my 6.1 rules. Okay, 11x minus 0.067 e to the 0.2x divided by 0.2. Now what I might do is see if that makes a nicer number. You know, 0.067 0.067 divided by 0.2. Yeah, that's easier for me to type in. 11x minus 0.335 e to the 0.2x. Okay, and you know, I could totally type it in as 0.067 divided by 0.2. That's just easier for me to type in, 0.335. And like I said, but if it repeated and went long, you might want to make a decimal out of it, 67/200, by pushing the double arrow button, or you can make it go back to 0. That's just easier for me. These are all the same. All right, so I'm going to do P of 25 minus P of 0. So let's do 25, store for X and enter. And type in my antiderivative, 11x minus 0.335, second function, ln 0.2x. And then that's 225.2816. I leave it long, just I don't round it to dollars and cents until the end. And here's a mistake a lot of people make here. People go, oh, it's 0, so I'm going to put 0 here. E to the 0 is not 0. So when I do 0, store for x and enter, and I plug it into my antiderivative, I get negative 0.335. So I'm going to let my calculator do that work for me. 225 number, enter, minus the negative 0.335 number, and my answer is 225.616, so it's 0.62. 225.62. And I'm putting these in my computer just to make sure I don't make a mistake, and then you're like, I didn't get that answer, it's wrong. Okay, all right. So that is, there are 2 more questions, and they're changed just a little bit. Okay, all right. So, but it's basically, instead of saying the first 25 items or the first 16 items, here's what we're going to do. Okay, so I'm going to put myself some writing. All right, so it says the marginal cost for a product is given by, so they're giving me the marginal cost, 232 plus 266 over the square root of x, dollars per unit, where x is the number of units produced and sold. And it says the current level of production is 164 units. If the level of production is increased to 269, find the increase in total cost. So if the number of units produced increases from 164 to 269, find the increase in total cost. Okay. So instead of integrating our function from 0 to a number, what are we going to do? We're going to integrate it from 164 to 269. Okay, so we'll set up our definite integral, always the smaller number on the bottom. And then it's 232 plus 266, and I'm going to move this x up. It's x to the 1/2 on the bottom, so when I move it up, it becomes x to the negative 1/2. Okay, and again, these are just going to be 6.1 rules. Okay, all right, so my cost function is going to be 232x plus 266x, and then when I add 1 to negative 1/2, we haven't had a lot of fractions, that gives me positive 1/2, and if I divide by 1/2, 266 divided by 1/2, and then I multiply it by 2/1. Okay, so I'm going to go ahead and do that before I plug in. So it's 232x plus 266 divided by 1/2 or 266 times 2, either one, is 532. X to the 1/2 from 164 to 269. So C of 269, always top minus bottom. Okay, so I'll do 269, store for X, enter. I'm going to type in my antiderivative, 232x plus 532x to the 1 divided by 2. Enter. So 71133.44876, and I'll just leave it long and round it at the end. And 164, store for X, and enter. And I go up and I highlight my antiderivative. And I get 44860.9242. So when I let my calculator do, I go up and grab the 71133 point number, enter, minus the other number, enter, and I get 26,272. .524 is 0.52. Okay, so 26272.52. Enter, and that's right. Okay, so that's my answer. Okay, so one last question. One of them has the square root on the bottom in the original. The next one has the square root on the top. So here we go. This is our last question. One more sheet of paper. Oh. Hang on, and then my music's loud. You can take a little break. Okay, here we go. Last question. More paper. And so this is the marginal revenue from the sale of X bottles of perfume is given by, so if they're given, this is question 7, the marginal revenue is 6.7 minus 0.45 square roots of X dollars per bottle. Find the increase in total revenue if the number of bottles is sold increases from 60 to 195. $60 to 195. Okay, so we have to set up the definite integral from 60 to 195, and we put our derivative, marginal revenue, 6.7 minus 0.45, and that is X to the 1/2, and it's positive because it's already up. Okay, I don't have to move it up like in the last one. I had to move that X up. So again, we're going to use our 6.1 rules to find the antiderivative. Okay, so my revenue function is 6.7x minus 0.45, and that's going to be x. When I add 1 to the exponent, I get 3/2. And remember, we divide by 3/2, or we multiply by 2/3. Okay? So I'm going to rewrite that over again. Now, remember, you can't round your antiderivatives. You could just put 0.90 over 3. This happens to give us a nice fraction. You just don't want to round your antiderivative. 0.45 parenthesis 2 divided by 3 is 0.3 x to the 3/2. Okay, from 60 to 195. So it's R of 195 minus R of 60. Okay, so let's get our calculator. Okay, so it's 195, store for X and enter. Okay, and then we plug it into my antiderivative. 6.7x minus 0.3x to the 3 divided by 2. Enter. And that's 489.59196, whatever. And 60, store for X and enter. And we go and plug it into the antiderivative and push enter twice and get 262.573. Okay. And why do I not really worry about so much what I'm writing down? Because I don't type these in again. I'm going to go up and I'm going to highlight my 489 number and push enter minus my 262 number and push enter. Now I subtract them by pushing enter again, and I get 227.019, so it's 0.02. 227.02. And that's it. And that's a 7 right here, 227.02. And that is marginal analysis and area of a function that's positive bounded by the curve and the x-axis. So we'll be back to talk about section 6.5 in a bit. Good luck. Let me know if you have questions.